Hey folks, it looks a little different from this side of the room. Hope everyone's having a good day. My name's Ken Osborn. I'm a technical marketing manager at Red Hat, focused on Edge. And one of the things I love is the history of our industry. And to the point where my spouse is like, stop collecting this old hardware. I've got old Commodore 64s, stuff that I started with that I fell in love with, in our industry, computing industry. Part of that is I love to hear about your origin stories. I'd much rather hear about your origin stories, how you got started, than blab about mine. As it so happens, I have the mic right now, so I'll share just a little bit about my background, and then we'll get into Edge Manager. I've been working in this industry for close to 30 years now. I cut my teeth at Best Buy Corporate. And this is a lot of probably old, boring stuff, but helped build the first .com presence for Best Buy. Probably more impactful to my career, I built and ran the virtualization practice. So thousands and thousands of virtual machines. While I was doing that, a buddy of mine was building the RHEL practice, right? And he went on to become a Red Hat employee. He went to the vendor side, right? I did a similar thing. I went to the vendor side only because I was working with virtualization. I went to VMware, where I worked for about 11 years. I was a field SE calling on pretty much every local customer here. I became a hyperconverged infrastructure SE as we were growing vSAN into a $1 billion business. I was tapped on the shoulder to help get an IoT product off the ground called Pulse IoT Center. VMware no longer has that. They sold that off. It's called SmartHub.ai. But that's where I got a lot of my early Edge experience because I grew up in the data center, quite honestly. I then went into the BU where I did technical marketing, which is what I'm doing at Red Hat. Now, the reason I bring any of that up is it's not gonna, when I keel over someday, it's not gonna say on my tombstone, here lies Ken, he loved to work, right? It might sound cheesy, but I love to help people. That's where I get a lot of personal satisfaction. So I bring this up because if you're sitting out there like I was years ago, staring at the presenters and saying, I could do that, or you're at a point in your career where maybe you do want to explore the vendor side, just reach out. I'd love to have a conversation with you. I can share my journey, connect with me on LinkedIn, send an email. If that's of any help to you at all, I'll make myself available. So enough about that. Let's talk about Edge Manager. This is unusual for Red Hat. Red Hat doesn't release new products every quarter, every half, every year. Very unusual. What are we doing with Edge Manager and why are we doing it? Well, this is a little bit of the marketing, right? At the edge, simple, scalable, and optimized for Edge. And I agree with that. The product was built for Edge. It's very lightweight, especially on these low compute Edge devices. So it's very friendly in that regard. But when I talk about Edge Manager, I like to talk about how we give customers and partners the ability to declaratively specify the things that you see on this slide at the edge, and if they drift for any reason, automatically self-heal them back to that desired state. So what are these declarative items? It's the underlying operating system. Right now at GA 1.0, that's the Red Hat family of OSs. It does require image mode boot C that Terry talked about, and I know the previous RUG, there was a number of sessions on boot C image mode. So the underlying operating system, the configuration of that OS. What do I mean by that? Well, dropping in an XML file to define a software firewall rule is just one example. Anything that you would do to that OS after you install it. And of course, the third item, probably the most important, are the applications, right? Organizations aren't deploying edge devices because they're bored and they have money to burn, right? Hopefully, they're getting applications out there that differentiate their business. They're doing something interesting. It could be a manufacturing scenario, right, where maybe they've got containers running on edge devices that are pulling in predictive maintenance information so they can understand when machinery might fail. It could be edge gateways talking to IoT cameras that are watching an assembly line and doing quality control. It could be a similar setup in a retail scenario where they're generating heat maps of customer population. You know, they're running promotions. They want to know, are these effective or not? It could be on a daughter board running RHEL attached to a drone. This is actually a use case that we're dealing with. So, folks, I've only got a handful of slides here. Most of this is going to be live demo. So I want to get your eyes on the product right now. I'm just going to cut over to a demo environment so we can do that. And I will leave time for questions too. And I'm going to try to make this bigger. Can you guys see that in the back? Kinda?
You can't see anything in the back.
All right. Well, what we're looking at is the Edge Manager UI. We call it REM for short. And I'm going to drill down on a device that's under management here. Now, in this case, we're using VMs to simulate physical edge devices. But this device, Drone 01, has been onboarded into Edge Manager. And if you can imagine with me, this drone's up in the air and it's doing something. It could be surveillance, it could, agricultural surveillance, it could be other things. But if you ever have that slow burn moment where you're doing some sort of deployment, you go to production and you're like, oh crap, I forgot to get something out there. That's a similar moment to what I'm trying to describe now. This drone is up in the air, it's doing what it's supposed to do, but it doesn't have its mission payload. There's no containerized app. Not a problem. We can correct that in flight by going to the device configurations here. I'm just going to click next. This is what we call the device template. Now this is for an individual device. The real power of Edge Manager is hundreds of thousands of devices in a fleet. In this example, it's just a single device. Already you can start to see, at least I hope you can start to see that we're mandating something here. There's a declarative specification that thou must be running this base image called edge-base-image. Okay, cool. But we need to get that application workload out there, which is what I'm going to do next. I'm going to go into the application workloads, click add. In this case, I'm just going to deploy a single container application that I've already built and I've published to a container registry somewhere. We'll call this drone cam. And now I just pass in the repository name. So I'm going to use my repo on quay.io, drone cam v1. I'm going to specify the ports that I want this container to be available via 8081. I'll click add. We can set limits, CPU and memory. My experience has been you start getting too cute when you do that, when you start trying to dial limits, especially in the virtualization world, but even with containers, you can outsmart yourself. So in this case, I'm not going to set any limits. I'm just going to click next. I'll unpack these policies in the second demo. We'll just click next. We'll hit save. And now what we see is that the device has gone into an out-of-date state. Essentially what's happened is the device has been given a new declarative specification, and the agent on the device checks in every 60 seconds. And it says, I'm here, do I match the desired state that I'm supposed to? And in this case, it checked in, it didn't match, and it was told, hey, you're not good. You're missing this application. You need to go and pull that. So that's exactly what has happened here. It's pulled that container, and I should have showed you this prior to say there's nothing up my sleeve, but that because we hadn't deployed the drone cam, it wasn't available. Now it's available. So this is actually something we built for a workshop. We were doing a fictional company where you deliver pizzas via drone. That's why you see like pepperoni run up here. But pretty easy just to get that container out there. And oh, by the way, I can go to the terminal here, which might look like SSH. It's not. There's no SSH daemon required. You don't have to worry about configuring any sort of network, exotic network config, firewall rules. The agent is communicating to the backend services in a mutual TLS encrypted tunnel using gRPC. Right? So really nice, especially for edge devices. You don't even need to know the IP address of the device that you want to manage. So I'm in what, again, looks like an SSH terminal. It's not. I'm just going to take a peek at that container we just deployed, issuing a podman command here. And just for grins, I'm going to kill it. And I'm going to try to do it, non-gracefully. What's that?
Waiting for the drone to follow this guy.
Yeah, exactly. It'll have no vision, no drone cam. So I'm going to kill it. And let's come back and see where that's at in a moment. All right, let's talk about the architecture a little bit here. Edge Manager is essentially just a set of microservices, which is a fancy way of saying it's a bunch of containers running somewhere. We can deploy Edge Manager on a single Rail box, or you can run it on OpenShift in a set of pods. At the heart of the microservices is the API service. So we have, from a user interface perspective, we tap into that API to paint the UI, or everything I'm showing you in the UI here today, you can also do via CLI. Now, tied to these microservices is an inventory database, Postgres. These are all your thousands of edge devices. It also contains the declarative state and the current state. You can bring your own Postgres if you desire. Now, I've sort of already talked to this, but this product exists because of the devices, because you want to manage something out at the edge. And these devices have to have an agent. By default, they check in every 60 seconds. And they say, again, I'm here, do I match desired state? One of the questions we get all the time, and it actually came up on another topic, like, what are your latency requirements to communicate? Is there like a 30 millisecond round trip latency? We don't really have to deal with that because it's basically the equivalent of an HTTPS web call, because the agent is tunneling everything through mutual TLS. It establishes we call it a long pole connection for 4 minutes. And if it sees a disconnect during that time, think of it as like a heartbeat or a keep alive. It just reestablishes that connection. Now, what I just showed you with the container demo may not have been apparent, but the agent checked in, the drone's up in the sky somewhere. It was told, you need to correct yourself. You're missing a containerized application. So it pulled that app from an OCI registry. It didn't need to communicate back to the Edge Manager backend services. So when you're architecting this, there are things like proximity. Like if you're in a manufacturing site, chances are you're not going to want to egress out of that. So you're going to want some sort of local OCI registry in order to pull containers from. The other thing worth noting here is we've tried to build this with a pluggable mindset. So out of box, we have these configuration, auth, and authentication providers. We're going to be adding more as we go. I'm going to show you another demo. We'll get the heck out of the slides. We'll live in the next live demo. This demo is just a very simple retail expansion scenario. There are 4 stores already existing across the US that are being managed by Edge Manager. The store composition is very basic. There's front of store point of sale kiosks, and there's some sort of device in the back of store, virtual, physical, doesn't matter, that's running the point of sale application. So the kiosks are going to run their point of sale app based on that device in the back of store. So what I'm going to show you is we're going to onboard a new store device in my hometown, Maple Grove. Doesn't mean as much to you all because you all live here. Before I show you this, though, I want to talk to prereqs just a little bit more. I've already mentioned that we require an agent. Today, we support image mode boot C. So you'll have to build that image, as we learned in the last user group. You'll build it as a container. And as part of building that, you'll have a container file where you'll specify things. And if you're able to see this, you specify, hey, what operating system do I want to deploy? What version? In this case, it's RHEL 9.7. We're also DNFing in the Edge Manager agent. By the way, you'll see a lot of flight control, flight CTL. That's the name of the upstream project. You can walk out of here today if you're interested, pull that down, start contributing to it right away. But we still have a lot of references to flight CTL in the 1.0 product. But at any rate, we've installed the agent here, and we basically have masked or turned off boot C's native update mechanism, because we don't want that to control the management of these devices. We want Edge Manager to be the system of record. So we mask that, and then we also bake into the container file enrollment information. It's in a config.yaml file. What is in here? Well, if you think about it, a technician takes an Edge gateway, they install it somewhere, they power it on, and they enroll it, and they walk away. Well, as that device is born into the world, it wakes up and says, where am I? Where's my mommy? Who should I talk to, right? Well, that's what's in the config.yaml. We bake in the location of the back-end enrollment point. So when the device boots up, it knows where to send that request to. All right, just a little bit on what I'm going to demo here. I'm kind of tipping my hand a bit, but we've pre-built a boot C image. We call it a base image. There are no applications in it. And we've attached it, in this case, I've attached it to a KVM VM that's running in a lab somewhere. Again, no apps, but it has an agent. What you're going to see is we're going to power on this device, and then we're going to join it to a fleet. And I'll unpack what I mean by a fleet. But joining it to the fleet is going to mandate that it boot C swaps to a different image. So why might this be interesting? We have a customer who works with a device OEM. They purchase their Edge gateways from. They give that device OEM a very simple, basic image with no pull secrets. They don't want any of their secrets to leave their premise. So the OEM puts that image on the gateway. It gets shipped to the factory site, and it gets joined to an Edge Manager fleet where it boot C swaps to a production image. That, guess what? Because it's on premise now, it does have pull secrets in it. So it can do things that it needs internally. So you don't have to give away any of your secrets if you're working with a device OEM. So that's what we'll see. We're going to join it to a fleet. It's going to mandate that it boot C swaps to a different image, and that image has an application already pre-baked into it. And this is where we get into a little bit of religion sometimes. I don't know if you guys have ever been in a debate around server naming conventions, right? And some people are like, you got to have the purpose of it, the location, the ordinal. And other people are, I don't care what that thing's called, right? I just care that it's online.
Comic book characters.
Right on. Comic book characters. I like that. Like the Batcave and all this stuff. Yeah, I've seen that. So you totally derailed me with that. Thanks.
It's so related.
Yeah, so similar kind of potential debates go on between image management. You have some people that want to pack everything they can into that boot C image. Other people, they don't want to have to crack that open every single time there's an update. So we give people the optionality to do as they see fit, where we stay neutral. All right, let's go back into the demo environment here. And this time I will show you, I'll actually hit reload. Maybe you trust me by now anyways, but there's no point of sale application available yet. What I'm going to do, actually before I power it on, let's take a little bit more of a tour through Edge Manager. This may not look so great because I've tried to make you all be able to see this, but what we're seeing here are 3 key areas. And respectfully, anyone that says they manage edge devices, we think they should care about. How many devices are under management? Are the applications online or not? Are the devices themselves online or not? Or are they in some sort of degraded state? We have a third item called system update. And you saw when I added that container that the device went into an out-of-date state. So this is us keeping track of are devices properly moving into their desired state or not, or are they staying out of date for some reason? Now, here's our list of devices. I'm going to make this bigger again. Again, I don't even know if you guys can see that. I'm going to set just a little filter here. What we're seeing now are the 4 stores that I showed earlier. These are the stores that are already existing. They're online, they're up to date, and they're a member of a fleet that we pre-created called Point of Sale Prod. So I'm going to drill down on this fleet, and we see things here at the fleet level. We see the same health status, if you will, only now it's specific to devices in a fleet. We also see the boot C image that must be running on any device that joins this fleet. It's called POS Prod. POS, point of sale, not the other POS. So I'm going to go in. Thank you. I'm going to derail myself again. I'm going to edit the fleet just to show you a few more things. We've just given the fleet a friendly name here, Point of Sale Prod. We tied in what's called a device selector. And this is nothing more than a key pair value of our choosing. It could be sky equals blue, environment equals test. In this case, it's POS equals prod. And how this works is any device that's tagged with this label automatically joins the fleet. So we can see that 4 devices match this. We can therefore conclude that the 4 existing devices must have been tagged with this label. They're a member of this fleet. I'm going to click Next. Now we see that same system image. Again, what we're saying here, thou must run this boot C image. If you're not running it, get out. You're not a member of the fleet. You need to correct yourself. We also have wired in a very basic host configuration here. In this case, I've just written a message of the day, into Etsy message of the day, and I've written in a simple message here that I want to be written into that file. I'm going to scroll down. This is our application workloads again. What I didn't show you before, I showed you a single container application. We can also wire in quadlet applications. Anyone familiar with Podman quadlets? Have you been working with those? You ever familiar with Docker Compose? Similar type of deal. Podman quadlets are nothing more than using systemd to manage local containers. So I'm sure you're all used to dealing with systemd, systemctl commands to start and stop those services, journalctl commands to examine their logs. That's exactly what we're doing with quadlets. And what we can do with this is we can write an inline config that's for more than one container. And I'll just give you an example here. So I would write this to the device somewhere. Let's just call it app.container. And I would paste in, if I had it here, where's my example? This is what a Podman quadlet file looks like. We just describe the unit, what's the description. We tell it what containers that we want to have pulled, what ports should be exposed that they should be running on. This is a very simple example. You can have very complex quadlet specifications. But the theme here, again, is any device that joins the fleet has to honor whatever I wired in here as a declarative specification. So I'm not actually going to apply this. I'll minimize it. The other thing we can do is we can track System D services. So for this fleet, we're just monitoring the time sync service, cron YD. All right, let's actually power on a VM. And again, this is a very simple example. This is just, I'm in a cockpit interface. We've got a couple VMs that are running on KVM. I'll make this a little bit bigger. We're going to actually power on the Maple Grove store here. This is, I know watching an operating system boot is about as exciting as watching paint dry, but bear with me. Yeah. So the operating system's coming online, and now we have a QR code that we could hit with our cell phone to go and approve the device if we wanted. In this case, I'm just going to grab a little screenshot here, copy it to my clipboard. I'll go to a public QR reader site. Hopefully there's not any offensive ads here. That looks pretty good. It wants me to download some stuff, but I'm going to paste in the QR code. You guys can't see this, of course, but there's a unique identifier that's been generated as well. It's a hash of MAC address and some other values, but I can open this link, and now I'm brought into the approval flow for Edge Manager, where we see some things. We see that the device is in a pending approval state. We see a CSR. I don't know about you guys, but dealing with certificates, also not the sexiest thing in the world. You want it to work. When it doesn't work, you want to bang your head against the wall. But it's necessary. It's important, especially if we're going to establish mutual TLS connections. So what's happened here is we've actually generated a device key, which can be stored in a TPM chip if the Edge device has it. And we've used that key with a temporary key to generate this CSR. We've sent this certificate sign request against the back-end enrollment services. It won't get its permanent certificate until we approve the device, which is what I'm going to do now. I'm going to go in and approve it here. We'll give it a name, Maple Grove, Store 01. I'm not going to join it to the fleet yet. I'm just going to approve it. So here's our device, and it's missing information because, broken record, every 60 seconds, the agent on the device is checking in. It's saying, I'm here, here's my desired state. In this case, it's actually going to start sending us resource information, indicating whether or not, CPU, disk, or memory are under pressure or not. While we wait for that, I can drop into the terminal. Again, not an SSH session. I didn't sacrifice anything to the demo gods, but so I can do stuff, right? When I'm in this session, I can say, hey, what version of RHEL are we running? I can issue a bootc status command, and we can see that the currently booted image is called edge.base-image. I can say, hey, are there any containers running here? There aren't. Are there any images? There are not. I can cat out the message of the day. There isn't one. Right? So you guys are probably way ahead of me in this demo, but what I'm going to do next is I'm going to join it to the fleet. What's the mechanism to join to the fleet? Tag it. That's right. Spot on. I'm going to tag it. I'm going to add a label. Point of sale equals prod. Right away, we see its fleet membership here. We note that it's out of date, and it starts chirping at us. It throws a warning. And this warning basically says, hey, wait a minute. you said to join this fleet, you have to be running a boot C image ending in POS prod. You're not running that image. You need to correct yourself. So that's exactly what's happening right now, is it's initiating a boot C swap to, in this case, a production POS prod image containing an application. Now, this is another really exciting part of the demo where we wait for an operating system to boot. So I'll pause for a little bit of air and just poll the room. Any questions? Is this making sense? Yes, sir.
Is this all controllable through a CI/CD like OpenShift is?
I'm very literal. So what we do support CI/CD pipelines with Git integration. So what we can do is we can tie in a repository and say, hey, devices, write the content that's in this repo to yourself. And so that the Git process can absolutely be controlled through CI/CD. Yeah.
Adding, or I guess would it be Ansible then to add new devices? Or?
Absolutely. Yeah, and we have an Ansible collection that's built just for Edge Manager. But the interesting thing about that scenario is we're changing the control point now to the Git repo, right? So instead of going into Edge Manager UI and doing stuff, we're relying on someone updating content in that repo, right? So we're kind of changing the doorway a little bit. But yep, good question. Anything else? Yes, sir. Dell.
Yes. So does this allow you to have Edge hypervisors then, right? Deployed as a bare metal, and then you run VMs on top, right?
You could, right?
Or applications.
Yes, either. At the end of the day, we're just managing today Red Hat family of operating systems. So you could be running RHEL somewhere with KVM as your hypervisor, spinning up VMs as part of that host config option that I showed earlier. Yeah.
And if you have a bare metal server, how do you provision that first before you can make it part?
You got to get that boot C image onto the device somehow, right? So Edge devices, typically you're writing something to some sort of removable media that might get SD carded into the device, or something along those lines.
So there's no special hardware requirements or anything to be any server?
Anything that's compatible today with boot C image mode. Yep. Yep, you bet. We'll grab some more questions in a bit, but what do we notice? We notice that the device has come back online. You can't see it, but it's actually saying the device is enrolled now versus you need to enroll. So if I scan this QR code, it's just going to bring me into Edge Manager, which I'm going to do manually here anyways. Here we see the device. We can see that it's online, it's up to date. We're getting tone off of its resource, CPU, disk, and memory. We are also running a different image here, POS prod. We've wired in a OS configuration or a source configuration, and we're monitoring that timekeeping service. So I should be able to hit my point of sale app here. There we go. We're Red Hat, we like red, so I know we already ate. Let's order like 99 glazed donuts. That's $128. You can't see that. I'll tender 130. Someone said that's cheap. We'll get some change back. We could print a receipt here if we wanted. I'll stop nerding out now. The app's there. If I go into the terminal, if we do a boot C status command here, we see that we're now on a different image, POS prod, and we have a rollback option, right? Because image mode boot C has an A-B mentality, we can deploy, have it swap to one image, we can roll it back to the other if we so desired. I can cat out the message of the day. That looks good. And I can confirm that we have containers running here. So what did we do? We took a device that wasn't running anything custom, no applications, no pull secrets. We onboarded it into Edge Manager, and Edge Manager informed the device that it was not compliant with the declarative specification of this fleet, and the device took action to correct itself. It pulled a new bootc image, it wrote a message of the day file, and it enabled the monitoring of its timekeeping service. One last thing I want to show you here, and then we'll open it up for questions. We've been in the UI quite a bit. You can live in the CLI if you prefer. Flight Control CLI, I'm just going to log in here. I know this is exciting, watching people log into stuff as well. Lab.local. I know, shoulder surfing syndrome is real. You're seeing stuff in clear text. It's not the only way you can authenticate. I'm logged in, so now I can do stuff. Let's make this even bigger. I can get my fleets. There's our point of sale prod. I can get my devices. This looks ugly because I've made it huge. I can copy the name of the device, and I can actually initiate a remote session through CLI. I can open a console connection here. Right, now I'm on the device. Let's cat out the message of the day, right? We saw that. By the way, if I nuke this message of the day, what do you guys think will happen? It's gone. It'll come back, right? Because the device is now no longer compliant with the declarative specification. And I never showed you the other device, the container. I'll show you that in a second. What you can also do in the CLI is you can edit the configuration of a device. So what I'll do is I will edit the fleet. Edit fleet point of sale prod, I think I called it. And what's that? Thank you. Thank you very much. Shoulder surfing syndrome. Thank you for paying attention. I appreciate that. So now I'm going to edit the fleet here. And I left out the word edit. All right. So here we see the specification for the device described in YAML. So all the OpenShift people in the world, in the room, this will look very familiar to you. We've got a device specification here, which is exactly what we were looking at in the UI. So what is its device selector label? What fleet is it a member of? What is its specification for applications, configuration, and bootc images? And if I scroll down on this, here you'll see the message of the day where we wrote that inline configuration. So I could actually go up here and edit this. Say, donuts. Exit out of this. Broken record. Devices, I've just updated the fleet specification, the declarative configuration. The device is not matching it. Hopefully it's checked in the time I just spewed those words from my mouth. If we go back to the device now and cat out its message of the day, we have donuts here. Very simple example. Now, I don't want to overhype this, but I'll ask you guys in a similar fashion, religious debates about naming conventions. If you've ever found yourself on a command bridge because something is broken and people are upset and there are executives on the call, and if you're worth your salt in troubleshooting, which I'm already feeling you are, you tactfully tell anyone that's non-technical to get off the bridge. I'll give you an hourly update. We've got work to do. What's the first question you ask? What changed? What changed recently? Right? Well, in this case, if we're managing these devices and either a junior engineer goes directly to the device because we have 3 decades of muscle memory that tells us we need to go and do stuff directly versus update the declarative configuration. If they went and changed something directly like that, or if there's a bad actor in the environment who went and started deleting things, the promise of Edge Manager is broken record. Within that 60-second window, the declarative state is healed back to that. You can get off of the command bridge. Chances are you would never have to get onto the command bridge because it self-healed itself. And in the world of Edge, where it's expensive to roll trucks to wherever, oil rigs, anytime you can eliminate the need for a human to go and do something, that should be goodness. That should help solve pain.
So to be clear, it only self-healed that file because you specifically mentioned it in your configuration.
Correct.
If you go delete a different file on that device, it will not repair itself?
Correct.
Okay.
Yep. We'd want to center in on, obviously you want to protect the integrity of the operating system,
Yeah.
but you want to center in on the applications as well, right? So if there's destructive actions against the applications, you can self-heal back to.
But yeah, I guess if each app has like a different volume or database or something like that, you wouldn't want all of them to just go through that if something changed. Right?
Potentially, yep. And it's kind of hinting at an important thing here. I made the statement that Edge Manager can manage hundreds of thousands of devices. We've regression tested, I think it's 100,000 today. The challenge with that is just making an assumption that to the point of our conversation, that we can unwind things. And so in your test cycle, you need to make sure that you're obviously validating all of that stuff, trying to break things, able to see it roll itself back. Yep.
So I imagine you could use this could you use it to update inventory to all the stores at once?
You can use it as a deployment mechanism. So we have customers, one example, they have store signage. So they've got an ancient, I wouldn't even call it an edge device, it's like an old PC that had been their mechanism to display store signage, promotional information like images or videos. So what we're able to do is get their devices a little more modernized, but use Git repository as the mechanism to update their promotional material. So they can go to that single Git repo, drop in whatever that new promo is, and the devices write that content automatically.
Is there a way in the declarative, is there a way to specify only one of, get something, for example, edit your declarative so that the Maple Grove store is the only one that shows a grand opening?
Yeah, there is, typically, this is where I want a whiteboard to explain this. Typically the boundary is the fleet itself, right? So whatever you've configured that fleet to mandate declaratively, all the devices have to adhere to. But we can get a little creative because we can have all the devices be in the same fleet, but pull from different areas of a Git repo based on labels that we tag the device with. So not device selector labels, but a label to say, hey, pull from this directory if you're tagged with US East. You know, if you're all the stores on the East Coast, pull from this Git location versus the US West stores, you know, pull from another. Yep, yep.
Where does the initial BootC image come from? Is it Edge Manager provided BootC image or?
I don't have it in this demo, but we're going to release a new version on, I shouldn't say the date, just in case we slip, very soon, that has image builder capability built in. So there's a left-hand nav item that kind of eases the burden of building that image. It's more of a, instead of having to build a container file and then use Podman to build off of that, it's more of a visual way to build stuff. So yeah, someone would have to go into either what I'm describing there to build their image initially, or get their hands dirty in a CLI and build that container file, you know, publish it somewhere that's accessible, some OCI registry. Yep. Yep. How are we doing on time? So today, Edge Manager is available via 2 offerings. You can buy it in our Red Hat Device Edge. If you're not familiar with that, that includes RHEL as well as a lightweight Kubernetes distribution we call Microshift. That includes RHEL, Microshift, and Edge Manager. Or you can just buy support for it with RHEL, just with RHEL and Edge Manager. iChart. And folks, that's what I had to share with you today. Happy to take additional questions. If there aren't any, we'll get to raffling an potential Edge device.